Hello there, children. Today we are going to review your wonderful and glorious Chapter 5 Common Assessment, which everyone I know deeply cares about. Alright, so this is problem number 1. It's graphing a parabola. How do I do that? Well, what you could do is do the following. You find your vertex, which is negative b over 2a. So you list your a, b, and c values right up here. And then you do negative b over 2a. That gives you your x value. If you remember, parabolas are symmetrical, so when you put that x into your t-chart, luckily for us, I know that if I find 2, which is 1 away from my vertex, I know what the same will be at 4. If I know 1, when I put x in, I'll also know 5, because they're both 2 away from my vertex. And then you simply just plug and chug. Okay, so now this one, number 2, looks a little different. I see this form right here. Well, if you recall, that is what we like to call vertex form, which means we do the following. This is vertex form. You should remember that. The opposite of the thing next to my x value is my x coordinate, and whatever this number out here is, that's my y coordinate on my vertex. Hence how I get negative 4, 2, because the thing next to the x was a positive 4, so a negative 4 goes in for my x, and then I simply use the y value given right there. Now again, how to graph this? T-chart. You plug and chug. Notice how my parabola is a little thin on the other one, and you graph it as such. Just plot your points. Now this particular problem, what we do here is the same idea. It's still vertex form, so I have my negative 1, which will be my x coordinate, and whatever that number is at 4 is my y coordinate. And now I center my t-chart around that, because I know I have symmetry. Once I find 0, I'll know negative 2. Once I find 1, I'll know negative 3, because 1 is 2 units away from my vertex. Negative 3 is 2 units away from my vertex. So, as you can see, 112 matches that particular y coordinate of 12. Now, you could not use this, but look here on my graph. I have so many x values to try that it is not beneficial for you if you don't use this method. Next, same idea here. What we end up doing here is you end up using, that's a negative 2 inside here, which means my vertex is 2 for the x-coordinate, to negative 3 out here, which means my y-coordinate is negative 3. And then I use a t-chart again, centering it. Again, that's your best bet. It gives you this nice, clean picture there. Now, if you forget how to do vertex, simply just plug and chug. You have 0, 1, 2, 3, 4, 5, and 6 as x values to try, so you should get a picture. Your picture must contain the parabola and must have its vertex so I know when it turns around again. This is a factoring problem. Now, for here, since I have a 3-term polynomial and the coefficient is 1 and there's no GCF, what I can say is give me 2 numbers that multiply to 54, add to a negative 15. I go through my factor list quickly here and I find, oh look, 9 and 6. I get negative 9 and negative 6. If you want, you can afford a check. This is all you need to do here. You can't solve anything, for there is no equal sign in the problem. So when it's a coefficient of 1, your life is much, much easier. Here in this problem, number 6, oh, that looks fairly awful. Yet remember, the first thing we try in factoring is a GCF, our good chumly friend. When I pull that GCF out, that's 6, I'm left with this. And oh, look, lo and behold to me. What I've got is a 3-term polynomial with a coefficient of 1. So all I need to do is figure out 2 numbers that multiply to an 80, but add to a negative 18. And that would be negative 8 and negative 10. Forward to check. Now remember, you can't just remove the 6. It's sitting out in front going, don't you forget to write me, otherwise it'll be wrong. So don't forget about that particular 6 there when you're factoring. This particular problem. Well, it's a 3-term polynomial. The coefficient isn't 1, and sad face for everyone, sad face emoji. We cannot pull out a GCF. So what I must do is use the rubber band method. What that says is multiply 4 times 21, or A times C, and get 84. Now I need to find 2 numbers that multiply to 84, but add to a 19. Those numbers would be 12 and 7. 12 plus 7 is 19. 12 times 7 is 84. So all I'm going to do is I'm going to rewrite 19. Instead of saying I have 19 B's, I have 12 plus 7 B's. And then I group the first two numbers and last two numbers together. And I pull out a GCF. The GCF of 4B squared and 12B, 4B. And I'm left with a B plus 3. The GCF between 7B and 21 is a 7. I'm left with B plus 3. Now look, there are two B plus 3's. That gets pulled out. And what am I left with? 4B and a positive 7. Now you could do this also by what's called guess and check. However, this method is guaranteed to work every time. Guess and check might not, and you don't want to waste that much time on this particular exam. Now here we have a two-term polynomial with no GCF. If you recall, and you should, this would be the difference of squares. So when I take the difference of squares, I square root the first number, get 4p. Square root the second number, get 5. When you square root what times itself gets me 16, 4. What times itself gets me 4? That's a p there, so 4p times 4p gets me 16p squared. 5 times 5 gets me 25. And then you simply just put it into the formula, and you FOIL to check. Now we are going to complete the square. Well, when I complete the square, what I end up doing is I cut b in half and square it. There's my b value. Because the directions say find the value that completes the square, and then rewrite as a perfect square. So when it says find the value that completes the square, hey, here's a hint, you should be using completing the square. So when I do that, I cut b in half, that's negative 13, and I square that. Negative 13 times itself, 169. Then factor this item. Well, you can factor that, two numbers that multiply to 169, add to negative 26, or you can remember when I cut b in half and I got that negative 13, that is the number that goes in my binomial. So that is all you have to do for that particular problem. This problem itself is a little tricky. So I'm going to use my properties of square roots we talked about. If it's under one house, I can split it under two. Same thing. Now I look at the square root of negative 16. We talk about square root of negative numbers. The first thing you do is pull out an I, and then the square root of 16 is 4. No problems. The square root of 7. I'm not expecting you to know what that is off the top of your head. It'd be great if you did, but you don't have to. But my rule is I can't have square roots in my denominator. So what do? I rationalize by multiplying the top and the bottom by the same item. That same item is whatever this is. So starting from the bottom, now we're here. I multiply the top and the bottom by root 7, and there's what I get. There's my answer. I've eliminated the square root in my denominator, which is exactly what I was going for. Oh, happy days are here again. Now this particular problem seems more confusing than it actually is. What I do is drop the parentheses and distribute if I have to. So here the plus sign doesn't change those at all. The negative sign here does change that to a minus 4i. And then all I do is combine my like terms. I go, all right, 8 minus 7, 1. 2i minus 5i minus 4i, well, that's a negative 7i. Put the I last, and lo and behold, you're done. Very simple for combining your like terms. You do not FOIL this problem, and I cannot stress it enough because, hey, there's a plus and a minus sign there. So you don't FOIL these. However, you do end up FOILing this problem because they are multiplied together. So you take first, outer, inner, last. Not a big deal, except you have to remember when I get 5i and 5i multiplied together, I get 25i squared. You cannot have I squared in your answer. It would be incorrect. I squared ends up being negative 1. So you get 25 times negative 1. And all it is combine your like terms at this point. Negative 42, negative 25, make it negative 67, negative 30, positive 35, 5i. That's all you do there. Well, what in tarnation is this? Well, it's division. So what I end up doing is looking at this. And I can't have i's in the denominator. Why not? Because if you recall, the square root of negative 1 is, in fact, I. So I can't have square roots in my denominator. So what I end up doing is multiplying what's called the complex conjugate. Fancy way of saying, you see this thing on the bottom right here? Yeah, that guy. Or girl, whatever. That thing right there. You multiply top and bottom by the same thing, except you change the sign out in front of I. That's it. The 6 stays the same. That 2i becomes a negative 2i. Why the heck do I do that? Watch what happens when I FOIL the bottom. First, outer, inner, last. The O and the I part of FOIL, that gooey, nougaty center, gets killed off. And I'm left with 36, and oh, I have I squared again. But I squared is negative 1. So I have 36 plus 4. That gets me 40. Oh, happy days are here again. I've gotten rid of my I. Woo! The top part, I really don't care if it has I's in it. I really don't care if it has I's at all. So, I get this when I FOIL that or distribute there. Now, the only thing here is, look, I can simplify this. And sharing is caring. Thank you. So, what I do here is I take a 4 from the 12, the 36, and the 40. You can't just cancel something like that out or that out. It's got to be from everything. And there's my final answer. Okay, this problem here, it's a solving problem. How do I do that? Well, what I could do is I could set it equal to 0, because I set everything equal to 0 except using the square root method and completing the square. So I'm going to set this equal to 0, and alright, b squared minus 4b minus 21, because I added 6 to both sides. What can I do here? Let me try to factor it. Two numbers that multiply to negative 21, add to a negative 4, well, that's negative 7 and a positive 3. But unlike before, now I have an equal sign sitting right here, and there, and there, and here, and here, and here, and here. I can end up solving. Set each factor equal to 0. Now, how can you check these answers? Why, you go ahead and, like a Glade, you plug them in, and you'll see they actually work in the original problem. So you can always do that. Okay, for this problem, notice how I just have a p squared. What I'm going to do is I'm going to isolate that using the square root method, something new this time. So what I do is I end up going over here, and I subtract 190, or 391, excuse me. Then I end up pulling out the 7 and setting each factor equal to 0. Well, that doesn't count being equal to 0 because it's a 7. Can't do that. So I get p squared minus 56 equals 0. Add 56, square root, and I get plus or minus, because I'm square rooting a variable, 56. Well, I can split that up as the square root of 4 and the square root of 14. Why do I do that? Because the square root of 4 is 2. So my answer here is 2 root 14. You also could have simply isolated the p squared at the beginning by itself and done the same thing. But I try to set it equal to 0 again to see what would happen. This particular problem isn't that bad either. It's something squared equaling something else. Well, heck, thank you, sir, for the easy slow pitch softball I can crush. I simply square root both sides. Undoing this, the gooey nougaty center falls out. I get plus or minus the square root of 20, which reduces down to 2 root 5, because 20 can be broken down into 4 and 5, and 4 is a perfect square. Then all I do is add 4 to both sides. Boom. I don't need the exact decimal answers here, folks. This is what I want. Need the plus or minus. Done deal. Not overly terrible. Alright, so this one, when I set it equal to 0, I get this. I subtract the 11 r squared from both sides. I get 10r squared minus 2r minus 1. I'm going to try to factor that. Well, newsflash, I can't. Shoot. Now I'm running out of options. I'm starting to panic a little bit. I have this creature, the quadratic formula, which can solve everything I want. Woo! Oh yeah! So I use that. And I go ahead and put my A, B, and C values into my formula and simplify them down. Just straight plug and chug. Doing all this work, I get root 44. Now, the square root of 44 can get broken down into 2 root 11. Now, what I have to worry about is the following. What I end up doing here is reducing this down, because I take it from everything, because sharing is caring. So I end up doing that and reducing them all down by 2, and there's my final answer. This run, same rules apply, no big deal here. I put my A, B, and C values into my quadratic formula. Only thing different is, I've got an I value to worry about now. When I reduce this down, not a big deal. I can deal with that. Reduce everything by 2, and there's my final answer.